All right, so I've known Adam for a long time. This is actually my first trip to Australia, though. I'm here to speak to you tonight about common ASP.NET design patterns. I'm on sort of a mini tour of the area with my wife, Michelle. We work at Telerik together. We run the services division there, and we're visiting some of our offices in India and Australia, and then Hong Kong next week. So it's sort of a whirlwind tour of Asia Pacific, Australia. Tonight I want to talk to you about ASP.NET design patterns. How many of you are ASP.NET developers? I'm hoping most of you are. Great. How many of you, by a show of hands, work with web forms? Wow, most of you. Like because you want to, like still today. Okay. How many MVC? Like, still probably some overlap there, right? Okay. So these will work with both ASP.NET MVC and web forms. Anybody using web pages? Right. Okay, that's what I figured. So pretty much no hands for that. But it's not really meant to be such a professional technology so much. All right, so I'm going to assume that most of you are familiar with design patterns in general, but I'm going to give a brief overview on that just in case you're not. And basically, design patterns are in software things that we can use as a reusable approach to a common problem. And so they're not exactly like a cookie cutter solution. You can't cut and paste a design pattern code snippet into your app and have it work. But when you see certain things in your application that are causing you pain, some sort of repetition or some kind of thing that doesn't really feel right in the design or it's overly complex, frequently there's a design pattern that you can use to address that will make it work a little bit better. And so tonight I'm going to talk about just a few of those that I've found to be particularly useful with ASP.NET, which I've been using since it was ASP Plus and before that ASP. So I've been doing it for a little while. Now before I get into the patterns themselves, I want to talk a little bit about learning, because I've found as I work through learning new design patterns, and there's many of them, and I don't know probably even half of the ones that have names out there, I go through these different stages. And this, I think, applies not just in software or to design patterns, but also if you're a musician or a martial artist or a sports player. I think you might be familiar with some of these stages as well. And I didn't do any formal research on these, so there's probably like scientific names for these. But these are sort of the stages that I came up with names for. And so in the first stage, I call this ignorance. This is where you don't even know a particular concept exists. Two other peers of yours might be talking about something. They use this word you've never heard of before. And you're like, what's that? And so the next stage after that is this sort of awakening where, okay, you've heard of this thing. Maybe you've heard somebody give a presentation at a user group about it, but you've never actually used it yourself. You don't really have a good sense of how it works, but at least you know that, oh, that thing, that's a design pattern. All right, cool, I get that. So then the next stage, if you really buy into the thing, this technique, this pattern, is typically you'll find yourself being overzealous. You'll say, oh, I heard about this great pattern. It's supposed to be better than sliced bread, and I'm going to try and use it on Monday when I go back to work on everything I possibly can. And I find myself in this stage all too often where I've just learned this new thing and now I want to plug it in everywhere. I think we as an industry do that sometimes with things like XML, where back in the day when that first came out, it was like, oh my gosh, everything's got to use XML now. And it wasn't until sometime later that we realized, okay, maybe some things weren't the best solution for XML. And then the last stage I think that we can get to is sort of mastery, where we don't even have to think about it. We have this as one of our tools in our tool set. We recognize when it's appropriate to use, and we know how to do so. So tonight I'm hoping, if nothing else, that I can bring you at least up to stage 1 for all of these, and maybe stage 2 for some of them if you really buy into what I have to tell you. And I expect that many of these you're already using, but I hope that everyone will get something out of this presentation. The other thing that is particular to design patterns as a worthwhile component is this notion of language. So all of these design patterns have names. And the nice thing about the fact that they have these names is that it allows us to communicate more clearly and succinctly with other software professionals. So when I talk to one of my developers and I suggest to him that maybe he extract an interface and copy the code into an implementation of that interface and then add a constructor that takes that interface and then in the constructor copy that interface parameter into a local field and then use that inside his code, that's a long-winded say of why don't you just apply the strategy pattern? And so we'll see that these types of patterns make it so we can describe common problems a lot quicker than describing all the steps that make them up. Now I did a poll about a year and a half ago on some design patterns and ran this just on Twitter. It's completely unscientific. And I asked people, like, of these design patterns, these are things that you've never heard of, or that you never use, or that you use daily, or that you use frequently. And so the ones that are on the far left are the ones that the most people said I use these daily or frequently. And the most common ones are the factory, followed by repository, iterator, adapter or wrapper, the observer, the command, singleton, strategy, and then proxy. And there were another dozen or so patterns that I didn't include on this list that were lower down the line. And of course, there's many, many design patterns. I'm not going to be able to talk about anywhere close to all of them here tonight. So for ASP.NET in particular, the most common design patterns that I want to talk about are listed here. And the first one is the singleton, which I'm going to give special mention to as an anti-pattern that I think you should probably avoid. But then the rest are shown here: the strategy, repository, proxy, command, and factory. And feel free if you have any questions as we go. I'll try and stop and ask, but if you have a question, just raise your hand or get my attention, and I'd be happy to take questions anytime. So of course, there's many others. These are the ones that I've found to be particularly useful. Some of these I'm still probably overzealous on. I'm guilty of using strategy pattern and the repository pattern everywhere, just because I found them to be particularly useful. So I don't know if the Highlander movie was popular in Australia. It was very popular for me back in the 80s. And the thing with the Highlander was that there can be only one. And that sums up the singleton pattern very effectively. And this is the Highlander SUV from Toyota.
We call it a Kluger.
It's a different thing here? Oh, all right. So you don't have this problem with there being two Highlanders down here. That's good. So let me talk a little bit about the singleton before we move into the patterns that I think you should use. And the intent of the singleton is basically to ensure that some class in your system only has one instance. And the reason for this varies. It might be that that class is expensive to create. It might be that that class needs to be the only thing that exists because it's got maybe an in-memory collection of things, and you don't need two copies of that running around in your app. You want to make sure there's only ever one of them. Now, with the singleton pattern, you make sure that that class itself is responsible for keeping track of this instance. And that's the part that I really take issue with. It's perfectly okay for you to have some part of your code that there should only be one of. The part I don't like is that the singleton is itself responsible for that. And so there can be only one. So here's an example of the structure. And I hope in the back that you can see this, but basically we've got a class called singleton. It has a private static instance of that same type. It's got a private constructor, which means that you can't just new one of these up if you're writing your code. The only way you can get one of these is through a static property called instance in this case, and that's typical. And then within that instance, we're going to say, well, if my local instance happens to be null, I'm going to go ahead and instantiate a new singleton. And I can do that here because I'm in the class, so the fact that it's private, I can still call it. And then in any case, I'm going to return it. So theoretically, the first time this gets called, we'll instantiate a new instance, and every request after that for an instance just gets the same one. Is this familiar to most of you? Great. All right. So what's the problem with this? Anyone? It's not threads. Yeah, I said that up there, didn't I? That's a good hint. Any others?
Testability and isolation.
All right. So testability and isolation is very hard to test, and because of the fact that this is basically a global variable at this point, it steps on things and you get side effects very easily. But the big one I want to talk about this particular implementation is the thread safety. It's very possible if you have a multi-threaded application, including an ASP.NET app, that multiple threads will enter into this if block and instantiate this thing. Now that might or might not matter because you've got this one singleton. If it really is that simple to construct, if the first thread creates it and then another thread creates it at just the same time, it's not a big deal. I'm going to add that to my presentation. There's going to be these warning alarms. When you see the singleton, you'll think warning alarms going off. All right, so that can be a problem, in particular if that is an expensive resource to create or if it does some kind of side effect when you create it. Having two threads in there at the same time can be bad. So the way you use a singleton is just like you would use an instance of a class. You can call methods directly. You can assign it to a local variable. You can pass it around as a parameter. These are all things that you don't necessarily typically do with a singleton, but you certainly can. And then this is an example. This is from John Skeet, who many of you probably know from Stack Overflow fame. This is from his blog, and he basically has a 10-page article on how to implement singletons in C#. And there's ways to do it that aren't thread safe, like I just showed you. There's ways to do it that are thread safe, but are slow. And there's ways to do it that are thread safe and fast, which looks like this. Now this is not anything I would ever possibly come up with. This is not at all intuitive to me. Is it intuitive to any of you that this is the way you'd code up a singleton if you had to today? No? All right. So if you do need one, the article for it is right here. But I'm going to show you a better way in a moment. But this is like the fast, thread-safe way to create a singleton in C#. Now, my preference, if you need to create a singleton, is, well, let me first off talk about the consequences, which we already covered. It's not thread safe. There's tight coupling. It's difficult to test. It's considered an anti-pattern for these reasons. One of the principles it violates is the single responsibility principle, which was one of the images that Adam showed from their software craftsmanship calendar with the Swiss Army mouse that you saw. And the single responsibility principle basically says that classes should only have one responsibility. And so a singleton automatically has at least two if it does anything, because it's responsible for its life cycle and it does whatever it does. So it's automatically violating that. So my preference is to use an IOC container to manage object lifetime, and I'll show you how that works in just a moment. How many of you use an IOC container today? Very many of you? About a third maybe? All right. And which ones do you use? Unity? Ninject? Unity? Any others? AutoFac? All right. So there's about a dozen of them, probably half a dozen that are particularly popular. One of my favorites is Structure Map, which is the one I'm going to show here. Before I get to that, let me tell you that you can use JustMock from Telerik, the professional version, to mock and test singletons and statics and things like that. But why would you want to intentionally write your code so that now you can only test it with these certain premium tools? That doesn't make any sense to me. So don't do that. If you're using an IOC container, which is an inversion of control container, what it does is it basically manages your objects in your application. And it gives you instances of them when you ask it for one. And in this case, with Structure Map, this is the syntax for how you would configure how it gives you these objects. So on the first line, we're talking about entity framework in this case. And with entity framework, you've got this DB context typically that you want to have one of for any given HTTP request. Or if you're running it on like a console app or a WPF app, you can just have just one for the app. And typically that's sufficient. So this hybrid HTTP or thread local scope basically says, give me one of these for the thread or give me one of these for this HTTP request. And it does all the logic of that behind the scenes. So you don't have to add an HTTP module or do any kind of goofy logic to make sure that you're always using the same instance. Just this one line makes sure that you've got the appropriate behavior for your DB context. If you want a singleton, for instance, maybe you're using nhibernate, and nhibernate is another ORM tool, but it uses this session factory object that you don't want to have one of on every HTTP request in a web application. You just want to have one of these when the app fires up. And if you do create one on every single request, your app is going to be very slow, so don't do that. So in this case, you can use a singleton, and to implement singleton, all you have to say is .singleton, and you're done. So you don't have to worry about, is it thread safe, is it fast, did I implement it right, I've got all this code. You can do this in the IOC container with one word, and it's a much better way, in my opinion, to handle this. And then the last line here is just the default syntax. If you want to have an instance every time you ask for one, and it should be a new instance separate from any others, then just don't say anything. That's the default behavior for Structure Map. Ninject and Unity, I assume, have similar ways of doing these same sorts of things.
What was the name of this one?
I didn't say that on there, did I? This is Structure Map.
Structure Map.
Yep. I didn't say it on the slide, sorry. And so yeah, Structure Map is a free open source tool from Jeremy Miller that's been around for a long time, like probably 8 years or so. It's very full featured, has support for generics and things like that. So it's my preferred one. It also outperforms most of the other ones, but there are a few that are faster. All right, so any questions about singletons or IOC containers or anything else? Great. All right, so next I want to talk about the first design pattern that I think is a good thing, and this is the strategy pattern. How many of you use this already today? Very many of you? Only a handful, great. So this is one of my favorite patterns, and I'll tell you why as we go here. So the intent of the strategy pattern from the design patterns reference book, which if you haven't got, it's a great hardback book to put on your desk that shows that you're smart and you've read these books. You put it on there with like refactoring and some of these other Martin Fowler books, and anyone that comes in your office and sees those books will instantly like add 10 points to their respect for you. You don't even have to open it. But so in this design patterns book, which is not light reading, it reads like an encyclopedia or a dictionary, they describe the intent of the strategy as to encapsulate a family of related algorithms, which doesn't really describe what it does very well, in my opinion. The other thing about it is that you want to let the algorithms evolve independently from the classes that use them. And so now we're talking about sort of dependency and breaking dependencies between things. And we'll see what that looks like in a concrete example in just a moment. Now the benefit of the strategy design pattern is that it lets you achieve some of these principles. So many of you, I hope, are familiar with the so-called solid principles of object-oriented programming. These are a few of them here: the SRP, single responsibility, which I already mentioned with Singleton. Also the open-closed principle, which says that you should be able to change how an object behaves without changing its source code. Strategy achieves that as well. I have a course on that stuff on Pluralsight if you're interested. The structure of strategy in UML looks something like this. So you've got this context that wants to use these algorithms, this behavior, your logic. So you create an interface. The interface is your strategy, right? So you might have an interface that describes how you write to the file system. And so you have like an iFile system interface. And then you can have multiple concrete representations of this. So you could have a Windows file system implementation. You could have a dummy implementation that doesn't actually do anything but helps you test. Or you could abstract it away and have a SkyDrive implementation or an Amazon Web Service implementation that uses S3. And now your context doesn't have to know what type of actual implementation it's working with. You've decoupled it from the implementation details of how you're going to actually talk to some kind of file system. So a common use for this is, as I mentioned, dependency inversion and dependency injection. I'll talk more about those as we go. This lets you decouple classes from their responsibilities. And when you have an example of a class that's too tightly coupled to its infrastructure, there's some certain steps that you can take. Basically, you want to identify the bits of code that are like too low level for the code you're working with and create an interface that describes those. And so you create an interface that responsibility. And then you create an implementation of that interface straight away that's got nothing in it except this one method that you need. And you take that interface code and you inject it into the constructor. And I'll show what that looks like in just a moment. And then you just take your actual implementation code and you just literally cut and paste it into your new implementation. So you don't have to change any of the code itself, usually. You just need to move it into a new implementation class. The other thing you want to do, and I'll look at real code in just a moment, is when you follow this pattern, you're going to end up with classes that tend to have constructors that take in interfaces that say, I need this, I need that, right? So you've got something that needs to save files. Instead of it doing it directly, it might have in its constructor a parameter that says, I have an iFile system dependency. And so when we have those things in our constructor, I think that we're being explicit about the requirements of our class. It's self-documenting. If someone new to your program or new to your team comes and looks at this class and they see, oh, to create one of these, I need to pass it in an iCustomer repository and an iLogger, well, then they know that those are the things that that class works with. Those are its responsibilities. When you don't write your code that way, if they try and implement that class and they just new it up and start calling its methods, they have no idea whether or not it's going to work. All right, if somewhere in there it's calling some static method that writes to a database, if they don't have that database all configured, it's not going to work for them. And they're going to beat their head against the wall looking through every line of code trying to figure out why this thing doesn't work, when if you'd simply stated in the constructor what its dependencies were, it would be much more clear. So I like to avoid hidden dependencies, which are dependencies that are somewhere buried in the class itself. You want to pass those in through the constructor. You can also want to avoid making any sort of non-stateless static calls. By non-stateless, I mean it's okay to call a method that adds two numbers together and gives you the result. It's not okay to call a method that calls a web service or calls a database or does some other side effect that affects the state of the application. Likewise, you want to avoid directly instantiating classes in your code if those are dependencies. If you're just newing up a string or a date time or something like that, obviously that's fine. But if you're newing up a customer object that goes and talks to the database, then that's creating a dependency that's making it difficult for someone to test your code in isolation. So I wrote a blog post, I think it was last year, where I basically said new is glue. So every time you see new in your keyword, think of that as glue that's gluing your code to that implementation. Anytime you create that, you're tightly coupling your class to some implementation detail. That doesn't mean you can't do it. It just means you need to be conscious of it, right? It's perfectly okay for our programs to have dependencies. They have to, or else they wouldn't do anything useful. But we want to be conscious of those dependencies and not just blindly implement or introduce dependencies that aren't necessary. If you need to remove tight coupling because you've got a new or you've got a static call or direct code in there that's working with infrastructure, that's when you can replace those with the strategy pattern that we just talked about. You can also use the strategy pattern with web forms, which I'll talk about in just a moment. But this is an example using structure map, where basically you can add a base page class, which in web forms I think is a best practice. In the constructor, you can say build up this page. Then in your startup script for your IOC container, you can tell it which properties it should set. And so here I'm saying set all properties of type iAlbum repository. And then if I create a page that has that as a property, I can work with that album repository without ever instantiating it in my web form, because it's going to get automatically set when the base page constructor fires by structure map. And so this is a nice way that you can do IOC and sort of a strategy dependency injection technique using web forms, which traditionally it's not that easy to do that with, because there's no way to hook into the constructor for the page. All right, so let me show you an example of strategy pattern real quick. And I don't need that anymore. There we go. Don't need that. And it's actually funny. Adam was just telling you about the enterprise music store sample, which I was not familiar with before today. I've actually chosen to use the MVC music store as the source of my demos, which I've sort of enterprise-ified myself by adding these design patterns and IOC and things like that. So this is a modified version of the ASP.NET MVC music store. And this is its home controller. And if we look at the store itself, let's go back here and look at some of the code. This is for the default music store. And I just want to show you its home controller by default, because it's easier than me changing it on the fly for you. So can I make this bigger? All right, so it's a very simple page. Hopefully you can see that. Let's see if I can make it a little bigger. Too much? All right. We've got the mouse on a slope, so it goes to the bottom of the screen anytime I let go of it. All right, so home controller. Very first thing it does, it's using entity framework, is right here. It says, give me a new music store entities. That's not even in a method. That's in the variable declarations. So essentially, it's in the constructor. So every time you create a home controller, you're going to get a new music store entities. This is obviously not good if you're going to try and test this without having a database, because every time you create this controller, you have to have a database or else this fails. Then in the index method, which is the only view that this thing supports, we're basically just going to get some albums using a helper method. And our helper method is just going to use that entity framework instance, that DB context, to go and get the top 5 selling albums. All right, so it's pretty simple. And this is designed to be for a new MVC developer learning how to do this stuff. But in this case, I think it's sort of teaching them the wrong things, because it's teaching them how to write tightly coupled code that's difficult to test, when in fact one of the main things that we see as benefits of MVC is that it's testable, which just goes to show that you can write bad code in any language or any framework. So if we use the strategy pattern to achieve this, we would follow the steps I just mentioned. We would take our existing code and create an interface for it. In this case, I'm going to call that interface iAlbum repository. And it looks like this. So here's this get top selling albums method. And then I'm going to inject that. So I'm going to create this private read-only instance of it on the class. And then I'm going to specify it in the constructor for the home controller. Now previously the home controller didn't have an explicit constructor. So I've added one now that takes this. If I don't do any more work in my code, and I'm just starting from scratch, this is going to fail to compile now, because all the code that's trying to create this home controller is expecting to be able to do so without passing in any parameters, and it's going to say no parameterless constructor defined, and it's going to give me that error. If any of you have worked with IOC containers, you're probably familiar with seeing that exception. Once we have this in place, we have to just set that local instance and then use that local instance in here. So at this point, we have no instances of new in this class. Right? So I've removed any part where I'm explicitly stating what I want to instantiate here. Now this little bit here I want to call out is if you're not using any IOC container at all, you can still use the strategy pattern And you can use it with your code that doesn't know about it, that's using your default constructor by default currently in your application. You can just create a new default constructor, by which I mean a constructor that has no parameters, and tell it to inherit from your new constructor, this one here that takes a parameter, and pass in whatever implementation you want. And so this is just my implementation I want to use for this particular album repository. So this is called poor man's IOC. It's where you don't have an IOC container, so instead you're going to pass in all the stuff in the default constructor. And it lets you implement the strategy pattern without breaking any of your existing code. So it's a good technique to know if you don't have the flexibility to suddenly go and add an IOC container to your application. Now if we look at that Entity Framework album repository, all I've done is take the exact code that was in my controller right here and just copied it and pasted it into here. So I didn't have to change anything else. I just copied that code, and now I've decoupled the controller, so now I can write tests against it without having to have Entity Framework running in that code. Any questions about that? Awesome. You guys are way smarter than most people. Usually they have questions. But I know I can't pander to you because you're too smart and good looking to fall for that. All right. So moving right along, let's talk about repositories. How many of you use the repository pattern today? Many of you? About half? Okay. So the repository pattern is very, very common these days. It's basically just a name for a data access pattern. And the repository pattern, as far as I know, was coined in the Domain-Driven Design book by Eric Evans. It might have been in a Martin Fowler book before that. I'm not sure. But basically, it lets us abstract away our data access. So our CRUD methods can go behind a common interface. And so our code no longer has to be concerned with persistence details. Those are hidden behind this repository interface. So before I show you how the repository interface works and what it looks like, let me talk to you about data access evolution as I've seen it in my career and frequently in projects. A long time ago, in a galaxy far, far away, we wrote our code and there was no separation of concerns. Whether you're using ASP.NET or even classic ASP, we'd have our user interface, and right inside our page load or our click method or whatever, we'd have data access. And we'd be using ADO or ADO.NET or whatever the data access technology du jour was from Microsoft. And so our code looked like this. We'd have a user interface, and it would talk directly to the database. And I have these two arrows here. The blue arrow represents what things look like at compile time. The red arrow represents how the code executes at runtime. And we'll see those are important as we move forward. So the problem with this is that it's very difficult to test. Everything is tied up into the user interface. There's no separation of a middle tier or business logic or anything like that. No abstraction at all. And you tend to get a lot of duplicate code, right? Even if you're writing different code, like you're calling a different store procedure on every page, you've still got all this boilerplate code to set up the connection and call the thing and everything else. So the next step that we frequently take is to make some helper class. And the helper classes, unfortunately, tend to be static. And so you'll call like the data access application block SQL helper that Microsoft shipped. How many of you have used that before? Right, I used that a ton. It was awesome. So it would take like 10 lines of boilerplate ADO.NET code and convert it into one line. But it was still a static call. So what ended up happening is you reduced some duplication, your code was a little cleaner, but at the end of the day, it still executed like this. Right? You had your user interface, you called into the helper class, it talked to the database. Now this is also representing our dependency. So everything now in our user interface is totally dependent on the database because these relationships are all transitive. So the thing that's missing here is any type of abstraction. And the abstraction that we use today typically is the repository. So previously there was no easy way to abstract away the data access. You had tight coupling to the database. And this tended to lead to like big ball of mud style systems. So the trick is to introduce an interface and have your user interface depend on this interface, this abstraction of your persistence. And so the structure that I choose to use today, which is the onion architecture, which what Adam was also talking about that you guys are giving courses on, which is awesome, basically uses names for these like core for the central project in your solution, and then another project called infrastructure typically where you put your implementation details. And so at this point now I can have my user interface depend at compile time on my core project and the interfaces that are defined in there, including this repository. But at runtime I can choose to plug in any particular implementation I want. So in this case I could plug in a SQL Server repository that actually knows how to talk to this database. and now at runtime we'll follow these red arrows through that particular implementation. But at compile time, there's no dependency on a particular data technology. And so I can write a test that uses a mock object or a fake object in place of my SQL repository and write tests against my user interface or against my business logic or my middle tier without having to actually have a database involved. Any questions?
Do you want to mention how these are notorious for leaky abstractions?
So, okay, so the issue of whether these abstractions are leaky, meaning like perhaps the abstraction that I choose to use, the types involved expose underlying details of my data technology of choice, for example, right? Or I expose an iQueryable interface that makes it so my calls to the database don't actually happen until I execute them, which might be well after I've disposed of the repository or things like this. So there are some issues that you need to be aware of when you implement this. But in my opinion, in my experience, the pros definitely outweigh the cons. But there's definitely some gotchas you can run into. Yes, sir?
So you said the code is a bunch of mock objects. What's the point of the code?
What I heard mock objects. What was the rest of it?
I'm just saying, is the code meant to be just a testable bunch of mock objects? What's the point of it?
Okay, so the question is the core meant to be just a bunch of testable mock objects? The answer is no. The core, and unfortunately in this example, the demo code I'm going to show you, I don't have anything broken out into core. But core is where your model objects live. So you'd have usually POCOs, like plain old CLR objects, for things like your customer, your order, your product, those types of things. In addition to that, you'd have your interfaces there, and any services that you have that don't have dependencies on infrastructure. So things that orchestrate between multiple different parts of classes in your application. There's no mock objects there because mock objects, in my definition, don't exist anywhere on the file system. The interfaces can be mocked by a mock object framework like RhinoMox or MOQ or what have you. And you can use those things to create a dynamic implementation of that class at runtime in a test that then you can work with that mock. So I'll show mocks in some code here, an example. How many of you use mock objects today? Very many? Half. Okay, how many of you have no idea what mock objects are? Don't be afraid to raise your hand. A few people. All right, so mock objects are great for tests. I'll talk more about them when I get into the code. They're basically an easy way for you to avoid having to write your own fake implementation of a class that you want to test. And they'll do things like let you know, like, I want this method to be called when I run this unit test, right? I want to be able to see, I go through this, I go into this if statement, I call this method on this object. I don't care what it does, I don't care what it returns, I don't care about any of the behavior beyond that, I just want to know that it got called. And a mock object lets you do that very easily with like 2 lines of code in your test. Instead of having to write your own class that implements the interface and then have some counter in there and then in the test say set the counter to 0 and then call the system under test and then verify that the counter got incremented by 1. That's a lot of tedious code that you have to write if you don't use mock objects for that kind of testing. Any other questions? All right. So then the repository, it's a data access pattern. It separates the responsibility of persistence from your business classes. It's a good idea to use what are called persistence ignorant business classes, meaning that they don't know anything about how they got there or how they get to and from some kind of persistence store. This enables the single responsibility principle again, because if you have your business objects using a pattern where they have a save method or a get from database method or in the constructor they automatically go fetch themselves from the database using like an active record pattern, those are difficult to test in strongly typed languages like C#. In languages like Ruby or JavaScript, they're easy to test because you can just swap out exactly what they do. But since we're talking about ASP.NET, they're hard to test. It also enables separation of concerns because now you can take all that data access logic, all that persistence logic, put it into a particular part of your code that's cocooned off away from everything else. That's, for me, that's going to be inside of an infrastructure project. And that makes it so that if you want to change from using Entity Framework today to using Hibernate tomorrow or something else, or Microsoft ships, I think on average over the last 12 years, 1 new data access technology about every 18 months. So there's going to be another one after Entity Framework. We don't know what it is yet. But you need to write your application so that when it ships and your boss or your customer says, hey, we need to be using Microsoft Vista data access technology. They probably won't name it that. You can go and swap that out and have just your repositories need to change. Or better yet, you don't have to change them at all. You just write a new one that uses this new technology and then you just plug in the new one instead of having to change the old one. It's common to have a different repository for each one of your business objects. So you might have a repository like a customer repository or an order repository, or it's frequently common to use a generic for that. So you can have an I repository of T, where T might be an order or a customer or whatever business object you're working with in your system. It's also frequently, so with repositories, this is not again, this is a design pattern. So it's not something where it's one size fits all. You can't just say, Google, find me I repository of T, copy, paste into my code, I'm done, right? It's a little more complex than that because you've got some design decisions to make. One of them is, well, there's a few of them. So one of them is where you want to decide to save. That's frequently one. So in an ASP.NET application, typically when I say, update this to that, and I call the repository's update method, I want it to do it. I want it to call the database right now, make that save. In a WinForms or a WPF application, maybe I want to do a whole lot of these updates and change the local view for the user, the in-memory representation of the objects that they're working with, but there's a big save button, and whenever the user hits save, well then it does all of that as one unit of work. And that's another design pattern that you may be familiar with, is the unit of work design pattern. And so when you write your repository, you might write it so that it has this explicit notion of save changes as part of its interface, where the user has to know to click that or else nothing actually happens. Or you might write it so that every single call explicitly saves the changes in there. Other things you might do is you might have a notion of bounded contexts, where when I save an order, I want to make sure that all the order lines get saved too. So if somebody added a record to the order or they changed an order record, when they save the order, all of its dependent objects get saved with it. That's something that's called a bounded context, because you don't want to save your entire object hierarchy, but you do want to save the thing and the things that are directly dependent on it. So you might have repositories based on each one of those. Another optimization you might do is take repositories and break them up into different logical operations. So you might have repositories for reading and repositories for writing, and then maybe a combined one that uses both. And the reasons why you might do that is because on read operations, you might want to introduce a caching layer, and I'll talk more about that in a moment because caching is one of my favorite features. And in the write operations, you might want to introduce a queue. And I'll talk more about how that can help performance as well in just a moment. So here's an example of the repository. This is the original MVC Music Store we talked about, and how you can shift it. So the first thing is pull out an interface, then copy all that implementation into a new implementation called the Entity Framework album repository, and then just inject this using dependency injection. And I showed you this already in Visual Studio. Then where do repositories live? Well, typically you want to put the interfaces into your core project if you have one. And that's also where your model classes go as well, and some services. The ideal core project in your Visual Studio solution has no dependencies on anything, right? So other than the framework. So it doesn't depend on Entity Framework, it doesn't depend on SQL Server or anything like that. Then you put your implementation into an infrastructure project. You might have just one, or if you have a really big project, you might have an infrastructure project for data access and another one for WCF and another one for something else. But you want to have those separate from your core domain logic so that your core domain logic is unit testable, but your infrastructure things can be tested with integration tests. And then your UI layer references core, but uses the implementation that's in infrastructure. Now, it doesn't have to have an actual Visual Studio reference to infrastructure, which is important. In fact, it might be a best practice for you not to have that, because that means that your new person that you add to your team isn't going to accidentally start newing up SQL repositories in the web form or in the controller and working with them directly, which they could. So you can do all of this without any actual reference to infrastructure. What having a reference does is make it so that when you hit Control-Shift-B in Visual Studio, it automatically copies everything into the bin folder for you. If you don't do that, you have to have your own mechanism to get those DLLs into your bin folder at runtime. Because at runtime, obviously, the implementation code has to be there. Any questions about this part? All right. I'll talk more about repositories at the end when I do a quick walkthrough. So next I'm going to talk about the proxy pattern. And the proxy pattern basically is where you have a class that stands in between another class and controls access to it. So in this example, we've got, Charles is asking Jonas what time it is, but he's doing it through a proxy. And when Jonas replies, he was replying back through the proxy. Now, in this pattern, the client, in this case Charles, has no idea whether or not they're working with the real thing or not. That's the beauty of the proxy, is that it behaves as the same interface as the real implementation that it would otherwise work with. So this is a class that controls access to another. You can implement this pattern through inheritance by subclassing the thing itself, or through delegation using a common interface, which is, in my opinion, the preferable way to go. Some frequent use cases for this. You can use it as a remote proxy for your web services or your network calls. So if you've ever used like an ASMX web service or most of the other web service technologies out there, they'll create a proxy for you, a C# class that you can code against, and it does all the actual work of talking over the wire to your web service or your WCF service. You can also use it for lazy loading. Entity Framework, or I'm sorry, NHibernate has a lazy loading feature that uses this technology where it basically has a dynamic proxy that it puts in front of the classes you're trying to work with and will only go and fetch the data from the database when something comes in and asks for it, rather than fetching everything greedily whenever you instantiate one of these classes. And then you can also use it for security and access control. The UML for this actually looks very similar to the strategy pattern. You've got the client that works now with an interface, doesn't know whether it's working with the real thing. There's the real subject, and then you've got a proxy that has a reference to the real subject and delegates to it. And then you can choose when you build your application whether or not to work with a proxy or work with the real subject itself. Alternately, the proxy could just be, as I mentioned, a subclass of the real subject. So one of my favorite features, as I mentioned, of ASP.NET is caching. If you're writing a web-based application and you don't have any caching in it, it probably could be optimized. You're probably hitting the database too frequently. However, if you're using the repository pattern, you don't want to go in and add caching to all of your read methods, because now you'd be violating the single responsibility principle. That repository now would know how to go and fetch data from the database and how to control cache access to that data and what the cache policy is and things like that. And so it would make it more difficult to test, and basically if you changed your mind about either the data access technology or how you do caching, you'd have to touch all your repository classes to affect that. But you can combine these patterns, and that's where they start to get really powerful. If you take the proxy pattern and you combine it with the repository pattern, you can create something that I call a cached repository. And it's basically a layer that sits on top of your repository and adds caching to it. So you want to have your caching separate. Okay, so here's what it looks like. So if you create a cached album repository, which is still implementing the iAlbum repository, and you put in all the caching logic, and caching logic, like the Singleton logic, is easy to get wrong. If your caching logic doesn't look something like this, which is using this double-check locking technique to make sure that we're not going into that code multiple times with the multi-threaded access, you're probably not doing it right, and you may end up with issues where you might get a null reference exception, for instance, where you expected there to be something there, but there's not. In fact, if you ever see cache code that says, if, so here I say var result equals cache as this type, and if result equals null, so I'm copying the thing in the cache to a local variable and then testing it. If you don't do that, if you just say if the thing in the cache is null, then I guarantee you that you've got a race condition, and your code, like 1 in 10,000 requests, is going to give back null, because at this point in the if, the cache won't have expired, and you'll be fine. But then down here at the bottom, when you say return that thing that's in the cache, it will have expired, and you'll be returning null. So don't do that. Now the nice thing about this code is that I can put this in one place in my application, and if later on I find a better way, I find there's a bug in how I'm doing caching, I only have to change it in this one place. Or if I have policies, like this isn't exactly how I'd write the code, but here you can see I'm saying the cache duration is 60 seconds. That shouldn't go there because that's a magic number, and I should configure that and put that somewhere else. But if this was the only place in my app that I did this, it'd be okay, because I'm not violating the don't repeat yourself principle. If later on I need to change that to 2 minutes, there's only one place in my code I have to go to change that. Now if this starts going into 20 different classes, now I've got a problem. Now the way this works is you'll see at the top that it's taking in an iAlbum repository in its constructor, and it's setting that to a local instance that's standard strategy pattern. So we're actually using the strategy pattern and the repository pattern and the proxy pattern with this one. And then it's delegating to it in here down at this line right here where it says result equals album repository. Now the trick for this is when you go use your IOC container, typically you're going to tell it something like, anytime something asks for an ifoo, give it one of these, right? So I'm going to configure my web application now to say, anytime something asks for an iAlbum repository, give it a cached album repository. Now the problem with that is that the cached album repository itself is asking for an iAlbum repository. And you can see there might be an infinite loop there when structure map or an inject or Unity gets confused and starts just trying to instantiate an endless chain of these things. Fortunately, you can do with structure map, and I'm sure the others can support this as well, something like this, where you can say, okay, for an iAlbum repository, use the cached album repository. That's all great, and if I stopped there, we'd have that infinite loop problem. But it also says its constructor, that .ctor on the second line, where it has a constructor parameter of iAlbum repository, use the entity framework album repository, inject that one. And so that allows me to achieve the proxy pattern here in a very flexible way, right? I did not inherit from entity framework repository, so I don't have to go when I change to another data access technology, now write a new cache proxy. I can just change one line here, and my code's very plug and play. It's like Legos, where I can swap out which implementation I want to use. Any questions about this? All right, and I'll show this in the code in the end when I get to the demo. So then I want to talk about, real quick, two more patterns. There's the command pattern. The command pattern basically lets you take some type of action and represent it as an object. How many of you ever heard in your school or studies about computer programming, especially object-oriented programming, that the way you do object-oriented programming is you turn the nouns into objects and you turn the verbs into methods? Did anybody ever hear that? That's pretty common. All right. So the customer says, hey, I need a store, and it's got to have a cart, and then when the customer hits checkout, they should buy the stuff. And so you think, okay, I need a store object with a cart object, maybe some products, and a checkout method. All right, so the command object is something that if you follow that, and that's the only thing you ever learn, you would never come up with on your own. So this is like a great pattern to learn the first time, because it opens up your eyes to a different way of doing it, which is that the verbs can be objects. And the cool thing about this is that now you can represent actions in a much more flexible and dynamic way. And there's a few things that you can do with this. So the nice thing about this is that you can decouple the action from the client that's issuing the command. Some common scenarios for this are delaying execution, logging activity. You can enable undo and redo technology with the command as well, because you'll know exactly what things they did as implementations of these commands. You can roll them back very easily. There's another pattern that's even better for that called memento, but we're not going to talk about that tonight. So let me talk a moment about delayed execution. I said earlier how it might be worthwhile to have your writes in your repository separated from the reads for performance reasons or scalability reasons. How many of you have ever bought anything from Amazon? Anybody? Great. When you bought stuff from Amazon, what was the next page you saw? What did it say?
You'll be receiving confirmation soon.
You'll be receiving confirmation soon. What else? Did it tell you all the products you bought and how much it costs and everything else? Did it? It doesn't for me. So it might be different here. But when you buy stuff, at least in my experience, when you buy something from Amazon, they say, thanks for your order, we'll send you an email. That's it. Right? They don't actually do anything when you buy something. All they do is they take a command and they put it on a queue. And they just send you back a plain old page that says, hey, we got your order. Now that's very scalable, right? They don't have to, there's no sticky state there or anything. There's no database calls. There's no checking inventory or any of that. They just immediately send you back a thank you page, right? It's very quick. Now most e-commerce stores on the internet, that you go and you use for yourself, they don't do that. They actually go and make a database call and they send an email and they do all this work in line and depending on how well architected they are, they do it all in the click command for the checkout button. But Amazon wouldn't scale that way, right? There's no way they could do that. And if they did, you'd click on it and you'd be like, go get a cup of coffee or tea, come back. Okay, Amazon's still working on that. So what the command does is it lets us decouple that operation. We can take that command object, serialize it, put it on a queue somewhere, and then later on, a minute later, 5 minutes later, something wakes up, pulls that off the queue and does the actual work, part of which is sending you an email that says, hey, we got your order, and here's the things you actually bought, and here's when we're going to ship it. And so we know, we're all conditioned that we're going to get that email. We're not worried about Amazon. They're not one of these fly-by-night companies. So the fact that we didn't see exactly all our order details when we hit checkout doesn't bother us. Most of us don't even notice it. We just see the thank you page and drive on. But it lets Amazon scale much more effectively than if they had to do all the work inside that UI thread when the user clicked. And there's lots of examples in our applications where we can do that same thing, where we don't have to make the user wait while we send an email or we do a database request or something else. And even if we don't have Amazon's load demands, we can still get the benefits of the scalability that this pattern allows. All right, so here's what it looks like. You've got your client, and you've got something that invokes things. You've got a command, and you've got a concrete implementation of command. Now, frequently, the command pattern, you only need to have like maybe one interface for. Right? You could literally just have I command in your core. And it could have one method, execute. And then when you create concrete implementations of that, typically in the constructor for them, they'll have all the things they need, right? So maybe the Amazon version of this is an I command, and in a constructor it says, give me all the details about the customer and their cart. It's really all they need. And then when you create one of these, you put it on a queue, it goes to some other process, it picks it up, and it says, for this customer, for this cart, run the checkout, and it does its thing. But you could use command, that same interface, for many other things as well, as long as each one could just have a call to execute. Another thing that command is great for is state diagrams. If you've got any type of notion of state transitions in your application, consider, for instance, I used to run a website called ASPalliance.com. Any of you ever heard of that or used that? It was big back in the day. It got bought by Code Project a few years ago. We had articles. And articles have these notions of states, like going from pending to edited to published. Maybe they get taken off and archived. And so you might go through these state transitions. The transition from one state to another often has things that are triggered that happen when it occurs, right? When you go and you say, I want to submit this to the editor, maybe you want to send an email to the editor team that says, hey, there's a new article in the queue that you can go edit. Maybe when the editor returns it back to the author, it sends an email to the author, and different scenarios like that. So every one of those state transition arrows can be implemented as a separate implementation of an I command or a command pattern. And what that lets you do is it lets you wrap all the logic of state transition into its own object that now you can test, and now it won't be repetitive. Because maybe there's multiple different cases where you go from these different states into one particular state, but they do different things. Maybe when you go from the editor and you kick it back to the author, it's different than if you go from the published article and you kick it back to the author. And you don't want to have like if logic that says, well, if the previous state was this, do that, and if the previous state was that, do this. It's much easier if you could just wrap all that into a command that you can now test. All right, so any questions about the command pattern? Awesome.
Sorry.
Yes?
Do you have some sort of code to show that?
Do I have some code to show that? Not exactly this, but I have some code that will show how we use the command in the music store,
Perfect.
which I'll show at the end. All right, so then the last pattern I want to talk about tonight is the factory pattern. And the factory pattern is essentially a way to construct objects. So you want to separate the way that you construct an object from the decision of which object to create. This might sound similar to what an IOC container does. IOC containers are basically, like I said, are responsible for creating objects and managing their lifetime. So IOC containers, to me, are just factories on steroids. So it's a really powerful and configurable factory. The other thing factories let you do is defer the creation of objects. And I'll talk about when that's important too for performance reasons. The nice thing about once you have a factory in place is it lets you add new implementations to your class without any of the existing classes knowing about them, because you've abstracted that away. So the factory could be updated either in the code or better through some configuration, through a database or a file. Maybe it's watching a folder where you drop in plugins. These are ways that you can decouple your code so that it now has more of a plug-in architecture. Possible places you can store things are in configuration or persistent storage, etc. Related to the factory pattern, how many of you use the lazy T operator in .NET? Anyone? One person, 2 people, 3 people. All right. So lazy T is available since .NET 4. So if you're on .NET 4 or later, you can use it. It's built into the .NET framework. There's a great article here. The slides will be available, I'm sure, afterward. I have an example of this that I'll show in just a second. But basically, if you don't have lazy T and you have one object that depends on another, for instance, here's an example of an order, and the order has a customer. And whenever I create an order, I don't always need information on the customer, right? So it would be a waste for me to go and fetch the customer from the database with all of its information every time I newed up an order. So what I can do is I can write code like this that says, okay, here's my private customer, and here's my, kind of like a singleton, right? I say if that's null, set it to this new instance. And then down here I've got this print label. And if I try and use my local, my private instance of that variable, it will fail sometimes, right? It can be a null reference exception. Now, it's perfectly okay most of the time for developers to use their private instance variables. In fact, it's frequently a best practice that you want to work with those and not go through the properties, because the properties might be doing special things that are separate for external clients of this class to work with. Now, with this particular implementation, I'm okay as long as I have this convention and everybody in my team knows it, that we will always go through the public properties. We won't use the private thing. But it's still a landmine that's waiting to bite people. If you switch this out to use lazy T, you can go and set an initializer here, and you say, I've got this new lazy customer which has this lambda expression that says, here's the new customer. So when you implement, or when you instantiate rather, a lazy T, you tell it the type of thing that it represents, in this case customer, and you give it some expression for how to get one of those. In this case, I'm just newing it up. So it's a simple lambda expression that says, give me a new customer. Now, my type that I use is a lazy T for my private variable. My public interface is no different, right? The classes that work with this class, they don't see any difference. They still see a public customer property. But now inside my code, it's perfectly OK for me to work with the customer initializer value here to get to the strongly typed instance of customer, or to work with the customer itself. If I work with customer initializer, my code's not going to work, but it's not going to work. It's going to fail at compile time because it's not a customer, right? So when I say customer initializer.address, that won't work. So I have to say .value.address, and that works, and that compiles. I'm never going to get a null reference exception with this code because whenever it hits that line of code, if it hasn't already been instantiated, it will go ahead and go do so. So this lazy access pattern is so common that Microsoft chose to build it into the framework with .NET 4. And most people aren't familiar with it, so it's part of my service to you here today is to share that with you. All right. Other ways that you can make factories, you can write your own method. So you can have a customer factory that has a create customer method that does whatever you need to do to create a customer. And you can do that, of course. Or you can use an IOC container, and like I said, they're basically just really configurable factories that have lots of conventions and such. With these patterns, I recommend that you follow what I call pain-driven development, which is you don't implement the patterns all at once for your new application and say, OK, I've got this new app. I'm going to use the strategy pattern and the repository and the proxy and the command and the factory and every other pattern I can get my hands on all off the bat. Instead, recognize where you see pain and where this can alleviate it. Typically, that pain looks like repetition. Right? You've got code that now is repetitive, and there's multiple places in your application that have the same concern, where you've got the same block of code doing cache logic, the same block of code talking to the database. This is providing you a way to create an abstraction and put that logic in one place so that you're not repeating it throughout your app. But don't try and use all these at once right from the start. All right, so I'm going to do a code walkthrough in just a second. Before I do that, let me tell you a quick real-world story of how the factory can be helpful. So I used to run with the code project, the Lake Quincy Media, which previous to that, Michelle and I ran, and then we sold it to them with ASP Alliance a few years ago. So Lake Quincy Media is an online advertising company. They just changed their name recently. Now they're Developer Media. And they show banner ads and things like that on a bunch of developer websites that you probably all go to. And so we have this ad engine that serves up advertisements, and it takes a fair bit of load because it's serving up 5 or so requests for every web page that developers go to across like 200 different sites and blogs and things like that. So it needs to be fast. And so it makes heavy use of caching. And it uses SQL cache dependencies because those things are cool. And the tables that are involved in Lake Quincy Media that describe the banners and the images and the things like that, they don't change that often. But when they do change, we want them to update immediately. So SQL cache dependencies let you do that and very effectively, so that we use those. So during a refactoring, we looked at some code that was doing this caching, and it had in there, it said, if this thing is null, create a new instance of it, put it in the cache, and add this new cache dependency. And we did some refactoring, and we followed some of these principles, but we didn't do it quite right. And we refactored the method, and we passed in, instead, this SQL cache dependency that previously was getting newed up inside that code, okay? Which should be fine, except for the fact that the SQL cache dependency class that Microsoft ships, it's part of ASP.NET, in its constructor, it makes a call to the database to see if the particular table you're talking to is enabled for SQL cache dependency. And so when you refactor your code so that now instead of only when the cache expires will I ever create one of these and then immediately put it in the cache so that the next call and the next call doesn't call this code because the cache is there, right? So it's like 99.9% of the time I don't hit this code, and 0.1% or less of the time I create a cache dependency. When you refactor that code so that now 100% of those requests create that cache dependency, it turns out to be bad. And it was some time before we noticed the problem, but basically like the memory would just go up like a sawtooth and then drop as it did a big garbage collection, and then do this again and drop. And this is a common thing you see if you have a resource leak in your application and you're trying to tune it. The bad thing about this is it was happening on every web server in our farm, and it was happening about every 2 minutes or so. And when it happened, everything got slow on that server for like 10 seconds or so before it came back on. So it wasn't good. And the thing that we needed to do to fix it was simple. All we had to do was, instead of passing in the actual SQL cache dependency, we just had to pass in a factory or a Lambda expression or even a lazy T, right? Instead of passing in the thing, pass in something that can give you the thing. And now, if you only need to create it some of the time in that method, and if it's expensive to create, this provides a very easy way for you to do that while still letting you pass in the thing that you want to be able to pass in. All right, so these are some references, which I'll come back to. But let me talk about some code real quick. I keep coming into SQL Server. I don't want SQL Server.
Steve, can I just interrupt?
Certainly.
I just want to encourage you to fill in the evals. Steve will be finished in about 20 minutes or so. But there are some good prizes. I've got some good prizes from Infragistics, from Developer Express, and from Telerik, so it's worth doing it. If you're online, guys, if you just put your email address in the chat window, and Raj will just fill out a manual slip for you and put it in the drawer. Okay?
Speaking of online, if you're online, my blog is at rdallas.com, and I'm on Twitter as rdallas. So if you're interested in that, if you have a question later and you want to be able to reach me, you can contact me through either of those. It turns out Steve Smith is not available in most of the places out there to get as a URL because it's rather common. So that's the name that I go by. So let's talk through some of these things that we didn't cover yet. So we looked at strategy. I think you guys get that. We talked about repository. Let's talk about how we can implement the proxy on top of the repository, because that I think is pretty cool. So in my infrastructure, which in this case I'm just using a folder for instead of a separate project, just to keep things simple, I've got these repositories. And one of them is the Entity Framework album repository that we already looked at. And it's very simple. It just knows how to talk to the Entity Framework and get stuff that I need. In a real implementation of this repository would have a lot more methods. It would know how to get, it would know how to list, it would know how to update and delete and create. For now, since I'm just refactoring the existing application, I haven't gotten there yet. So I've only created a few of the things that I need to be able to test the home controller and a couple other controllers. But in a real example, you'd have more methods there that would cover all of your CRUD operations. Another common question with repositories is, should I return back iQueryable? And basically, iQueryable is cool because it lets you use LINQ to make queries against something. Personally, I don't like returning back iQueryable from a repository because of the fact that it tends to have that leaky abstraction where now you could be working with this iQueryable in your controller and you use some LINQ expression that should be perfectly valid, but because under the covers, it's really an entity framework repository, it's doing something where it only works with certain types of methods or certain types of objects. And if you use like an extension method where you say, well, give me all the albums where, call this extension method that checks to see if the album title starts with A, right? And it's, your own custom extension method. Well, Entity Framework's going to look at that and say, well, I don't know what to do with that. That's custom extension method. It doesn't exist in the database, so I'm going to blow up and give you some weird error that you're not going to be familiar with. Whereas if you just return back an IEnumerable or an iList, that'll work every time. And your extension methods will all work like you expect, and that's all good. The downside to that is that if you're relying on things like lazy loading, you won't be able to use lazy loading if you always return back an IEnumerable because it has to actually go get the stuff from the database at that moment in time and hand it to you as an IEnumerable or an iList. And so that's, again, a design trade-off that you can make. With the caching, the actual implementation is slightly more involved than what I showed in the slide because I also have pulled out the cache dependency that I'm using into an iCache dependency factory. And what this is letting me do is exactly what I just explained a moment ago with the real world scenario where you don't want to pass in the cache dependency every time because it's expensive to create. And so by passing in a factory, now when I actually need that, I just create it right here. And I say, okay, give me the cache dependency I need right at this moment instead of every single time I call this method. And if we look at this, that's not what I want. If we look at this, this just creates a new cache dependency, but I have a note here that says, that right here, it says this is expensive. Don't do it unless necessary. So factories are a great way to defer creation of objects, especially when you don't always need those objects. If you only need them once in a blue moon inside of an if statement and they're expensive, then pass in a factory, don't pass in the thing itself. Let's see. So with the proxy implementation, I think I covered that pretty well. Again, this implements iAlbum repository. it has one of those passed in through strategy. Here's the constructor. Here's where it gets set. And then in my IOC configuration, I specify with that constructor parameter how to set that. So if we run this code, let's first look at the IOC bits. IOC. So this is how you configure structure map. And right now, I have it hard-coded to say that I'm going to use the iAlbum. Whenever I have iAlbum repository, I'm going to use the EF album repository. All right, so if we run this code and we look at the home page, you'll see at the bottom of the page there's going to be 5 albums if everything works right here. So Nevermind, The Best of Men at Work, these 5. Those are coming from the database. And so I just made a database call on that request. And on that request, and that request, and that request. And obviously that's bad. And I can fix that maybe with output caching or different other caching techniques. But those all have limitations. If I have any kind of custom logic on here, like here's my cart and how many items are in it, if I output cache this page and I'm not careful about that particular bit, I might accidentally have different users seeing different people's carts information on that page. And so output caching might not work in this case. The nice thing about implementing your caching at the data layer, where you're making those requests with the repository, is that you don't frequently have that concern. But we do definitely want to cache this because it's silly for us to hit the database on every single page load. And so to implement that, all I have to do is switch this one. Oh, no, of course, Visual Studio still can't debug while I'm running. All right, so do that and replace it with this one. And now this is that exact same code I showed you, where it's going to say, whenever I need an album repository, use the cached one. Inside of that, use the EF one. And now if we run this again, it's probably not going to work. So I probably broke something. Okay. Yeah, it is. I fixed that. So it's telling me that the album table is not enabled for SQL cache, which I actually enabled it right here. I said, album, enable it, done, you lie. All right, so let's try again. Oh, it's using a different database. Okay. Well, I won't try and debug this while I waste your time here. But this would theoretically work, and it would only then run the cache dependency at that moment. What other questions? Okay, command. When is command helpful? So let's talk about the checkout for this. Which is actually in the shopping cart. No, where's checkout? Thought it was here. All right, yeah, here it is. All right, so this is the code that actually runs when you check out of the MVC Music Store by default. Essentially, there's this method called address and payment, which is the last thing you do when you're checking out. And you say, I have this new order. And then down in here, we got some logic. And the original code that is in there right now, if you download this from Codeplex, basically says, take my StoreDB, which is a local direct entity framework reference, and add an order, and then call save changes. So it's just immediately talking to the database. The new code that you could use if you wanted to change this to be more like Amazon would be, I'm going to create a new command, and I'm going to put the order into that command. I'm going to create a new command processor, which is going to be my order processor, and I'm going to queue up the order. And that's all I'm going to do. And then I can be done. I'm going to do whatever else I do with the UI or the redirects or things like that. But this bit right here replaces the actual work of saving it to the database. Now to make that stuff work, you just need to implement this command. And so the order command, I've got an interface for called iCommand, which like I mentioned can be very, very simple. Just has a single thing called execute. And then the order command right there basically does the work, right? So I took the work and I put it inside the order command. So it's got the exact same logic that I had inside my controller before, where it didn't belong. You shouldn't be doing data access directly inside of your views and inside of your user interface layer. I've now moved this into an order command, which is living in an infrastructure project where it belongs. And it's talking to entity framework. This part I would obviously swap out and pass in a repository. And it's doing the same work though. So here's, I'm going to process the payment, I'm going to save the thing, I'm going to send notifications, etc. All the work involved with an order would go in here. And then the processor I don't actually have fully implemented, but the processor would basically have some logic to add the command to a queue, and then here it would just execute the command. So it's sort of mocked up in this case. You could use any number of things for the queues. There's Azure queues, there's Amazon queues, there's what's the other one I've used? There's N-Service Bus, which is nice for that kind of thing. There's MSM queue. So there's a ton of different things out there that will let you implement queues for this type of thing, where it's multi-process, multi-servers, not just the simple queue type that you can use to make this kind of thing happen in your application. So then the last thing I wanted to show, because somebody asked about mock objects, was how this enables some testing. And so if I go down to my test project here, and we look at my, let's just look at home controller. Here's my home controller test. And this is just using Microsoft Test, and so I'm going to create a mock repository here. In this case, I'm using the mock framework MOQ. I mentioned there's also Rhino mocks, those two are open source. Telerik has their Just Mock thing, which is free for the version that does all the same stuff this does, or there's a commercial one. The basic steps for any of these are the same though. You set up what you want it to do. So in this case, I'm going to say, okay, I have this repository. I want to set it up so that when something calls get top selling albums, it returns whatever I want it to return. In this case, I'm going to have it return this method call, get test albums. And I'm going to say it's verifiable, which means I want to know whether this actually got called. Then I can new up my controller, and my controller now does not have an empty constructor. The only way you can create this controller now is if you pass in one of these iAlbum repositories. And that I'm doing right here, this mock repo.object. That object is the actual implementation of that interface. Now it doesn't exist anywhere in my code. I can't go find a file that's called mock album repository.cs. It's literally creating that thing at runtime, which is handy because it means I don't have to create a bunch of these files and keep track of them. Then I just run the thing. So here's var result is call the thing. And I call this verify method. Verify is going to say every one of these methods that was verifiable, return true if it was in fact called the way I expected it to be. If it wasn't called, it's going to throw an exception. And it's going to say, I expected you to call this method and you didn't. So the test would fail. And then I can do some other things. I can check, did my model in fact come back as a set of albums? Did I get the view name I expected? Did my model have in fact 5 things in it? My test albums method that I mentioned basically just gives me a list of 5 albums, just news them up. So it's very, very simple code there. But this does not have to talk to the database at all. And now if I run this test, hopefully this will actually work. Yeah, there we go. So it passes in 174 milliseconds. And if I run it again, it'll probably pass even faster than that. There. So now they're 15 milliseconds. I just ran all the tests, but they're all single-digit milliseconds except for the first one, which is when the test is loading up the test suite. So unit tests are much, much faster than integration tests, typically, because they don't have any dependencies. So I can run like 1,000 of these in a second or two. Whereas if I was hitting a database, I could run 1 of these in a second or two, or maybe 5 or 10 of these in a second or two. So they scale much, much better. And that's why writing your code so that you can avoid those tight couplings to infrastructure like the database is important, because it lets you make your code testable in a very fast fashion. And if your tests are not fast, you're not going to have very many of them, or you're not going to run them very often because they're going to be painful. And tests that you don't run don't really give you much value. So they're actually a cost because you have to maintain them. So make sure that if you're going to use tests at all and you're going to bother, keep them fast and keep them useful. Any questions about design patterns, mock objects, IOC containers, Telerik? Yes, sir.
Just in terms of like mock objects, when you're building them up, it's often potentially repetitive code. Do you normally use factories to build up your
Certainly.
code base?
Certainly. So the question was, when you're using this type of coding in your tests, it's frequent that this code here gets rather repetitive. And so just like in your your regular code, if this starts to get repetitive, you should use some kind of a refactoring to take away that repetition. Put it inside of a helper method, put it inside of a factory, so that you don't have this same code repeating in every single one of your tests, certainly. Because it will happen that you're going to change the interface for your classes, or you're going to change which mock object you're choosing to use. And you don't want to have to go and change 1,000 different tests to make that change. You want to be able to go to one place and make that change, just like your production code. So the question is, do I use the unit of work pattern much? Yes, but I don't necessarily use it explicitly as a separate thing with its own interface and everything else. The like Entity Framework, which is what I use most of the time in things these days, has unit of work kind of built into it. It's got a save changes method. It can do all that. So I usually just use it and then expose that through my repository. So the question is, where's the best place to start? Shameless plug for the design pattern library on Pluralsight that I've written a few of. So if you have access to Pluralsight, you can get a free trial for like 100 and some hours or something. That's a good spot. Also, these 4 books are all excellent. The first one is just the reference by what was it, the Gang of 4, and it's from like 1997 or something. It's or maybe older. It's all written in like C++, I think was the language du jour.
92 and half small talk, half C++.
Okay, 92 and half small talk and half C++. Okay, it's even older. These other 3 books are much more readable. If I was going to pick one, pick Headfirst Design Patterns. It is like the best book for actually learning design patterns and teaching it to you. And it does not read at all like any other programming book you've ever picked up. It's very, very dynamic and interesting to read. So they do a very good job of keeping that interesting. So the question is, do I have a hard time selling IOC? And by selling, I assume you mean to developers, not to management or what have you. So do you test that code then? Because it's easy the first time, but then when you go to write the test, it starts getting less easy. Okay, so yeah, so if they've already drunk the Kool-Aid, as it were, about testing, then it's usually an easy sell. It's like, well, you can't test it doing it your way, but if you do it this way, it makes it testable. And a lot of times developers didn't know that that was possible. They didn't know that there was a way to do this decoupling. They didn't know this pattern existed before. So I think, for me at least, 5 years ago, I didn't know about these things. And I wish I'd known about them, 10 or 15 years ago, because it would have changed a lot of crappy code that I wrote. So I think it's a good thing. And setting it up is really pretty easy. For you to set up Entity Framework, for you to set up Structure Map in an MVC app, you can just use NuGet and say install package structure map -MVC, whatever version. And you're pretty much done. And it will go ahead and add this. So in MVC, I've got too many windows open. MVC has this notion of a dependency resolver. That's an MVC type. And this little bit of code right here that says get service is where you inject in your IOC container so it does the work of getting the types. Specifically, you want it to get your controllers because it wants to look at the controller and see, does this controller have a constructor that takes some interfaces that I know how to fill? And if it does, then it automatically fills them in for you. Once you've got that, then you've just got this little tiny bit of configuration code. And another nice thing about Structure Map is it has this thing here called with default conventions. And I don't know if the other ones have this. But Structure Map, basically, if you add this with default conventions, it says that any interface that you call, I repository, let's say I have an I order repository. If I also have a class with that same name without the I, so I have a class called order repository, it automatically will use that one. All right, so.
I have a question from Eric Lam. Preferred dependency injection framework.
Structure Map?
Repeat the question.
So the question from someone remote was, what's my preferred dependency injection framework? Which I think is the same question as IOC container, but I could be wrong. You could ask him, does he mean IOC container? Because otherwise I don't know what he means.
Yeah,
But I would say Structure Map. Okay. So this convention thing means that I don't have to go in for every single interface and every single type and add another line of code to this, which gets tedious. Question in the back. So the question is, what about the performance? Won't this slow my code down and make it horribly slow? And the answer is that for 99% of the apps out there, you'll never notice. Now some of them are faster than others. So for instance, Ninject, as I understand it, is one of the less fast ones. And there's one out there called Func, which uses all Lambda expressions to do its thing, and it's the fastest one. And Structure Map is in the middle, closer to the Func side. But most of the time, it won't matter. So if performance is a concern for you in your application, You should be testing for it. You should have an idea of what your required performance is. And one of the things that I like to tell people is that if you're past good enough, then you're wasting time. So if your performance is already good enough, then trying to make it more performant and micro-optimize it is wasting your customers' money when you'd be better off giving them more features. Now that's not always true. If you're Amazon, there's probably always some benefit to being faster. But for a line of business application, if it responds back in 500 milliseconds versus 400 milliseconds, the user's probably not going to care. And in this case, we're talking milliseconds to microseconds for this stuff to happen. So anytime you have extra method calls, anytime you have reflection, it will be a little bit more work for the servers and a little bit less on performance. But the gains that you get on maintainability, I think, are worth it in most of the scenarios. You've got to test it, and your mileage will. Do you have that expression here? Your mileage will vary. All right, so your liters per kilometer may vary. All right. Well, thank you very much, and I'll be around if you guys have questions afterward. Thank you.